I'm Ryan St.Clair from Illinois FTC Team 14683, the Lincoln Way Central Robotics and Engineering Team, and I'm here to show you our 2018-2019 rookie season competing in first, Rover Ruckus. Let's start with some background. As founder and head engineer of 14683, I'm proud to say that our purpose here is to focus on passing skills from the experienced to the inexperienced, and all around getting our school, Lincoln Way Central, excited about competitive engineering again. Now I say again because our school used to be a powerhouse in the best robotics competition and could confidently advance to nationals each year. Since that team had unfortunately disbanded years ago, 14683 seeks to put Lincoln Way Central back on the maps, and the best way to do that is to develop a robot with a simple, robust, and reliable design, along with countless hours of tireless work invested into it. Meet Walter, our weird autonomous lifting teleoperated robot. With Walter, we were able to obtain first place design award and place as a winning alliance finalist in our league championship, which advanced us to the Illinois State Championship. Walter exhibits impressive capability on the Rover Ruckus field, including a consistent teleop score of at least 70 points, along with running a full autonomous routine with landing, sampling, depositing a T marker, maybe not that aggressively, we'll tone it down later, and parking into the crater. But many other robots at the league championship could accomplish just as much as we could, so how did we advance the state and earn the design award? Why us? Well, we can attribute that to two major designs that made our robot strikingly distinct from the others: our latching system and our collection system. To make it this far in our first year, we needed a way to confidently keep our head above water whose surface height was set by other veteran teams. In Rover Ruckus, we decided that if we could reliably attain 80 points from lifting and landing, we could maintain the pace of experienced teams. I told my design team that we needed a simple, rock-solid, and proven design for a latch and lift system that could reliably get us those 80 points. Now let me show you what they came up with.
Alright, so quick thing about the lift mechanism. So we actually use servos. We almost use the DC motors, however, the servos allow us to have a better locking, and it also means that the use of servos allows us to actually use our four-wheel drive. We use chain in here. We had the option to use a string or rope. However, we had some bad experiences with it. It's not as strong as the chain. A little bit more of a pain to get set up in the beginning, but it's worth every minute of it.
For the latch, I was thinking very simple, and I needed it to have no moving parts. I needed it to be light and also strong. So I have L brackets and two poles and some rubber bands here to make in a one-way saloon door system type thing. So it locks when you go pushing up and it opens when you push down. Holds up the robot very strong, really reliable.
Ultimately, as the championship approached, we needed a way to distinguish ourselves in the competition. After seeing our latch and lift system get us those 80 points each match, we focused our priorities on getting more points during teleop mode, because at this point, all the pros could accomplish all autonomous tasks more or less reliably. Now we needed that extra push to put us amongst the finalists.
For our arm here, we needed a way to make this extend, so we thought the best way and the quickest way would be a rack and pinion. So here I have 3D printed a rack and pinion that has a herringbone gear system. So the servo just moves up and down and it extends the arm with it.
So our collection box design was really stupid simple because we needed it pretty fast. All it is a cardboard box supported by a metal bracket with a piece of surgical tubing in the middle, so that once it goes down and grabs the ball, it can go up without the ball falling out the bottom. And we have these lips on here so that when it goes back to dump the minerals, they don't fall out too early or fly out in the wrong direction. And this little middle bracket creates a convenient carrying case.
Because of this collaborative setting, we were able to make a robot competitive enough to advance us to state in our first year. As a matter of fact, the robot is even what I'm most proud of in all of this. I created this team to make a lasting impression on my school, and to do that, I had to set an environment of collaboration, fearless idea sharing, and teamwork to really set this team in the right direction. Did you notice how involved they were in the discussion of each of their respective mechanisms? They would never have been able to do something like that when they first started. Now, our robot performed amazingly, but I had to ask myself, how can I make sure that these guys will build another robot just as successful after I graduate? That question is what led me to what I'm really proud of in all of this, the team, which is what this year's robot was really all about. We didn't just engineer a robot, we engineered a culture.